Hello, welcome. Today we're going to be looking at UML, Unified Modeling Language, which is simply a graphical language that allows software developers to use a standard notation in developing software that every other software developer will understand. So when you're using UML, you're simply using a universal language, graphical in form, that enables you to use standard notations in your design so that anybody can see it and understand. A Python developer can look at your UML and start developing a software in Python. A Java developer can also look at that same UML and start developing a software in Java. A C# or C++ look at the same UML. So it's a standard notation. It's standard notation collected together that enables programmers to plan their project. This is the way the project has to work, and this is how it has to look. This is the first step. This is what is needed. So that is what we are going to be looking at. And in looking at it, we are going to be using use cases. There are many other ways of looking at it. So you can use use cases where you use use case diagrams. You have the class diagrams. Class, like I said, the components of the software has to be visualized like objects that has features and functions. So you have a diagram for that. You also have what we call activity diagram. So to start with, we are going to be using use case description. Use case description is actually a method that describes everything the app does step by step. So for example, we are looking at the use case description for a calculator. For you to use a calculator, first of all, the user clicks a number button. You have to click a number button. The user clicks a math button. If you want to add 1 plus 1, you have to click the number button 1 first. Then you click a math button plus. The user clicks another number button. Then you click another 2 so that you're doing 1 plus 2. So a number button, a math button, and a number button. Now then the user clicks equal to button and the result shows. So after clicking the first number button, you click a math button, click another number button, then you click equal to give you the answer. So that is a use case. Use case simply means what is a user required to do whenever he is looking at your software in order to use that your software. So after stating this use case, you have to state notes like the problems or challenges that you're going to get when you're using this use case. Number 1, since every button requires the previous button to have been clicked, make sure the click occurs. Before you click a number, you have to make sure that you've clicked another number in order for you to add them. Number 2, make a way to track which math button was clicked last. In order for you to have a mathematical operation done, you have to let the software know that this is the math that you want to, whether it's plus or minus or anything. Think about a way to handle the user entering both single numbers and multiple numbers. Make sure you have a way of entering 100 instead of 10 and 0. Let it be 100. If you want to enter 1, 2, 3, let it be 123 instead of 1, 2, and 3. Track the first number in the entry after the math function is clicked. You have to track the first number in the entry after the math function is clicked so that you know what happens with the next number that you're adding. Then finally, note 5, take care of integer division by converting everything to float. Make sure you convert to float to enable easy mathematics. So these are the use cases. The use cases I stated before, 1 to 4. Then the notes, which are the challenges that the user might encounter. So these challenges you have to take care of it. Whether you're using exception handling or any other method, or you code a small code snippet to handle these challenges so that your calculator can work efficiently. So using this use case, we are going to develop our first big software, and that will be a calculator. Very importantly, you might have to describe this our use case using the use case diagram, taking out class diagram, activity diagram, and the rest, depending on how large the software you're creating is. But you see that if you're creating a simple calculator, you might just use these use case statements and just delve into our software creation. But very importantly, when you're working on a big project, you have to state your use cases, just like we've stated. You have to identify the classes. You have to, when you identify the classes, you have to identify the functions and the attributes of those classes, features and attributes features and functions of the classes, because we are looking at it as in the perspective of object-oriented programming (OOP). So when you're doing that, you have to do your class diagram, you have to do your activity diagram and other things before you start the actual coding. But if you're doing a very simple software, you can just simply use the use case and you get onto the work. Most importantly, make sure that you state the use case and the notes, which are actually the challenges that could be faced when you're trying to solve or when you're trying to go through this normal use case. Like in this very first use case, you consider note 3. So as you are considering user clicks a number button, consider the note 3, which say think about a way to handle the user entering both single numbers and multiple numbers. User clicks a math button. Check about number 1. Since every button requires the previous button to have been clicked, make sure the click already occurs. So as you're writing this code, you might be writing this in functions. You say def this, def this. Make sure you take care of all these in your code snippets. So this is where we're going to be ending for Unified Model Language for now. Subsequent classes will look at it more. Please hit the subscribe button to subscribe, like and share our videos. Thank you. God bless you.